There we go. The contrast is about the same as when we had the potentiometer. Hello again. Welcome to the next part of our adventure with the LCD and an Arduino. Today we actually want to do something that doesn't have any code involved. Okay? Today I want to talk to you a little bit about something that I said in the past we'd touch again later. So if you remember when we wired everything up.
Yes.
So there's a 5 volts coming off the Arduino across this red wire, and then this black one goes back to the ground. So voltage is a complicated thing that I'll tell you more about some other time. It's something you'll learn more about and a little bit about, and learn a little more. But all you need to know right now is these 5 volts is from the red to the black. Right? Voltage is a comparison between two places. It's the difference between a thing called potential between the two places. So this right here is used to measure that, and a couple other things. This is called a digital multimeter. It's digital because of the way it's built inside. That's not the important part. The important part is that it's a multimeter. Do you know what multi means, Sister Yeti?
Lots.
Yeah, it can be lots. Multi for multiple. Multi meaning there's more than one. So lots is multi as well. Now, if you have more than one, well, that's multi, but what is meter? Do you know what a meter is?
No.
Something that measures something. Okay, so you measure a thing. So this is a multimeter. It can measure multiple things.
Oh.
So when we look at the dial here, you see it has this V with the squiggly over it, AC, and a V with 2 lines over it, DC. That is AC voltage and DC voltage. Won't get into the details of that, but this is DC, and what comes out of the wall when you plug it into the wall, that's going to be AC. So basically just means, is the electricity always moving one direction? That's DC for directional. Or does the current, the electricity, go back and forth, back and forth, back and forth? And that's AC, alternating current. There is a difference between those, and it affects how everything's wired up. If something wants DC and you put AC on it, it can break, and the other way around as well. So this circuit is all DC. So if we wanted to measure the 5 volts coming off of that, we can put this down here, and I'm going to add a couple of wires here just to make it easier to get at the wires.
Wow.
Because these right here aren't small enough to go into the holes on the breadboard, right? So to measure this, I'm going to hold these to the wires. Now, I'm only holding these myself because I know that's only 5 volts, and 5 volts will not hurt me. If this were a more powerful voltage, I would not be touching these with my fingers, okay? So if you don't know how many volts it is, do not touch it with your fingers. But I know this is 5 volts, so I'm holding it like this, okay? But you notice it's moving around a little bit. It's because I'm moving. If I hold still, it settles on 4.87. So it's almost 5 volts. It's not exactly, it's close. So everything that's on here, it expects it to be almost 5 volts, and it is almost 5 volts. So everything here is fine. Okay? So this is giving us 5 volts, and we measured that with the multimeter. This part of the meter is a voltmeter.
Oh.
Okay? It measured the voltage of that part of the circuit. Now, what it measured was how many volts there were between what I touched with the black and how many volts there were and what I touched with the red. So the difference between them was 5 volts. Now, what do you expect if I touch these together?
It would measure on that. I think nothing happens.
There's a 0 because there is no difference. Neither of these is providing a voltage, and so when I touch them, there's no difference between the voltage. Also, same will be true of the desk. It's the same object, right? what about this metal thing? If I touch the other parts of this metal casing with, I'm not touching it yet. What do you think it's going to be?
Maybe it's still going to be 0.
Yes, it's still going to be 0 because it's the same piece of metal. So there can't be a difference between it and itself.
Yes.
It's the same thing, right? Okay, so why did we get the the digital multimeter out? Well, the potentiometer is being used to control the contrast, if you remember, of the display. If I turn it one way, I can't see it. If I turn it the other way, everything turns just all the same kind of darkness, right?
Yeah.
So we need it somewhere in the middle so it looks good.
Yeah.
Okay? In a coming project, we want the potentiometer for something else. But I only have one.
Oh.
I can go get another one, but we only have one in this kit.
Okay.
Okay? So I want to replace this potentiometer that we're using right here with something else.
Yeah.
So we can use the potentiometer for another thing. Okay? Now, this, I explained a little bit the first time we used it, is basically an adjustable resistor. Okay? Got some excitement coming from Sister Yeti here. This isn't a resistor, and there are markings on it that are very hard to see in this light, but there are a bunch of little lines on it that are different colors. And those all mean how much resistance. They tell you how much resistance is on that resistor. But we're not going to learn how to read those. There's could maybe do that sometime. But the paper has 1 M for 1,330,000. So that's how many ohms a resistor has. The resistor is measured in ohms, and the ohms is, the bigger the ohms number, the more it resists the electricity flowing through it. And so that gets into current, so higher resistance lowers the current. We're not going to talk about current much today. But what we do need to know is that these different resistors have different values. Okay? Now, if I grab these ones here, I set these aside because these are the ones we're going to use. This says 10K on it, right? Let's turn that around there. 10K. So I just spun this around to 200. Let's put it to 20. There's a 20K there. This is the ohms section. Okay? This is to measure resistance. So now, since this says it's 10K, if I put this across, what do you think it's going to tell me on the meter?
10K?
It should be.
I think 10C.
See? It's very, very close. Okay, it rounded down. It's very, very close to the 10. Cool.
10-1.
And we know it's 10,000 because what I set it to here was 20,000. If I put it on the 200, it will also read 10. But notice that the decimal place moved over 1. Right? So the other setting is meant for reading higher, bigger values. And these smaller numbers are meant for reading. It's more accurate at smaller numbers. Okay, so we also have one that has a 5 on it.
5K. Okay.
Okay, and it says 5. Cool.
Cool.
Now, let's just go through the rest of these. This one says 1 on it. These are all really accurate. Some of them can be a little bit off. One of the lines on the resistor tells you how precise it is. Sometimes they can be 5% off, which would mean for a 2,000, like this one, it could be like 1.98, 1.97. That would still be within spec. Okay, so those are all what they say they are. Okay. Now what we need to do is we need to figure out which resistors we need to replace this potentiometer. Okay, so this potentiometer is a 10 kilo ohm potentiometer, is what the spec says. And we can see that here on the the sheet in the project box as well. It says it's 10 kilo ohm. So to measure that, let's go ahead and unplug it so there's no power. So for this, I'm going to put these in here, and it says 9.1 something. Not quite 10, right? But it's close.
Yes.
So let's actually move this keyboard
Yeah.
so I can do this a little easier. All right? Okay, so this is 10, more or less.
Oh, 16.
Now, I mentioned current a little bit ago.
Okay.
The higher resistance limits current. We don't want you don't want current to be too high. It can damage things. So we want the same resistance from the 5 volt to the LCD as what this has right now. So I can't just put in a 1K, or that will make the current will be higher and that could damage it, right? So I want something that is similar. Well, this potentiometer is 10 kilo ohms total, but it actually has 2 wires going to this side and 1 coming to this side, right? The potentiometer is actually more like 2 resistors.
Okay.
Like this.
Oh.
See, if I make a V with those resistors, notice that that's kind of like having it's the 2 wires up here and then the blue one comes out the bottom, right?
Oh, yeah.
So, like this is what's called a voltage divider. The voltage between the red one to the black one is 5 volts. But the voltage from blue to the red depends on what this value is. When we move the potentiometer around, when we spin this around, what that does is it changes the resistance on one side and the other. All the way one way makes one side 0 and the other one 10, and all the way the other way makes one side 0 and the other side 10. And if you put it right down the middle, it'll make it 5 and 5. I won't get into why it divides the voltage today, but what that means is if these two are the same, if this is 5 volts K and this is 5K ohm, then what comes out the middle is going to be half. We've got 5 volts between here and here, and if these two resistors are the same value, then the voltage that you measure here is going to be half. Because we're going to have half the voltage here and half the voltage there. So what if this was 1 and that was 4? Right? If that's 1 and that's 4, then the voltage here is going to be 1 and 4 together make 5.
Yes.
And 1 is 1 part of 5. And so the voltage here should be 1 volt.
What? I'm not.
Or 4, depending on the way it's arranged. I'm actually not entirely sure which way it's arranged. But the point is, now if we measure from the red to the output of the potentiometer, it should be somewhere between, I need to put this back to voltage, it should be somewhere between 0 and 5.
Oh, what?
And what is it?
Okay. 3. Point 40.
Yep, 3.4. Okay? So it is something between the two. Now if I do it to the black one, it's going to be about 1.2. The 1.2 plus 3.4, that's 4.8. That's about the 5 volts. Right? So part of the voltage is on one side and part of the voltage is on the other. So together they make about 5. So what we need to do is we need to take these resistors and put them in here in a way that will get us the same voltage from here to the same voltage measurement as when we have this potentiometer.
Okay.
Okay? So,
Okay.
let's unplug this. We don't have power going through it. These, I didn't keep track of which is which, so I'm going to just set them aside and we'll figure out which is which later. But we want a 5 kilo ohm. So 1.4, 1.2 and 3.4, one of them is about 3 times the other one. So if I put a 2 and a 5 in, this one's the 2, this one's the 5. The 2 is not quite 1/3 of the 5. If I put in a 1 with the 5, what's 1 plus 5?
1 plus 5 equals 6.
6. And then that is 3 times the 2. And then 2 plus 5 plus 1. So what's 2 plus 6?
2 plus 6 equals 8.
8, yeah. That's not quite the 10 we had before, but it should be close enough.
Yeah.
If we wanted to make it more exact, we could put another 1 in here, and then put a 2 here, and so this would be 7 and 3.
Okay.
You know, I think I'm going to go ahead and do that. So let's put that 1 there, and let's put a 2 over here. Now, 3 and 7 is closer to 1/2, so it's not going to be the exact same as this. Okay? It's not going to be the same as what the potentiometer says right now, but it should be close.
Wow.
So now we need to put these together. How do we add these resistors together? Well,
Wait.
if you put them in series,
Yeah, I think.
if you put them in a row, one after the other,
What?
their resistance adds up.
What?
Some other time we'll talk about what happens when you put them next to each other. It actually makes the resistance lower because now your electricity has more paths to take. It's like if you turn on 2 hoses of water, now more water is flowing because there's 2 hoses. There's 2 paths, so there's more electricity flowing. But if you put them together, there's still only 1 path. So what we need to do is I'm going to move this blue wire over a little bit so the potentiometer can stay where it was.
Okay.
Okay. And now I'm going to put this resistor, one end of it is going to go in the same line as the blue wire.
I can remember why you made that.
Okay. And then I kind of ran out of space on the breadboard, so let's go ahead and move that out of the way.
Yeah.
We can put that back in for the next project. So I want one end of this resistor on the same line as the blue wire.
Okay.
Because the blue wire is kind of the output. And then the resistor is going to come over here somewhere.
What?
And then I need that resistor to connect to the red. Red was on this side.
Yep.
So I'm going to put the resistor on the same line there. These two are on the same line of the breadboard.
Yeah.
And then I'm going to put the other end in the red. And so that replaces the red wire that we had. Remember there's a red wire from here to the potentiometer?
Yes.
So the potentiometer inside has resistor. And so we replaced the potentiometer with these two resistors. And that replaces the red wire. So it went from the red line to the blue. Now we need to do the same thing on the other side to the black.
Yeah.
So I'm going to use
I remember.
pliers to push that in. And then I'm going to put
I remember
it over
why
here.
you made that.
Yeah, the pliers make it a lot easier to push these wires in because the wires are skinny. They're hard to, and they're slippery. And so if I hold it with my hand, they slip easily. So the pliers make it easier to hold them. So then I'm going to put one end into the same line there, and then put the other end in where the black wire was on this line. Okay, so now in theory, we're going to see this together. We're going to see if that works the way we expected, and the screen should be about as dark as it was before. So now if we plug this in, of course it's hard to see on camera. There we go. The contrast is about the same as when we had the potentiometer in.
Yep.
Pretty cool, huh?
Yeah.
Now we can't adjust it anymore, but that's a pretty good value. I think that's very visible for us in real life. I might play with it more off camera at some point to see if I can get the value just right for visibility. But that's pretty good.
Yep.
Cool. Measure the voltage now. So from here to here,
Much.
it's 2.8
Okay.
ish. From here to here, it's about 2.
Yep.
So it's not quite the same as the 3.6 and 1.2 we had before, which is why this isn't quite as visible on camera. I want to get those a little bit closer to each other. But it is close enough to what the potentiometer was set at for the purpose of today's lesson. Okay?
Okay.
Is that pretty cool? So you can measure things with the multimeter. You can divide voltages using resistors to make a different voltage measurement come out over here, right? So from here to here is going to be about 5 volts, but here in the middle, it is a different value depending on which side you measure.
I know.
Okay? Well, that's pretty fun. Now we have a potentiometer available for the next project that we're going to do. Okay, so like I said, off camera, I made some adjustments to make it a little bit more visible. I made a small change to the resistor pattern that we have here. So before we had, I think it was 3 and 7. And so 3 and 7 is not quite what we wanted because we wanted a 1 to 4. So that would be 2 to 8. No, that's not quite right. We wanted a 1 to 3. Sorry. We wanted a ratio of 1 to 3. And so that would have been 2.5 to 7.5 to make them equal 10 together. But I don't have 500 ohm resistors, so I couldn't do a 2000 plus 500. I just had a 330. And so what I ended up having is a 2.3 to 5 plus 2 to make 7 plus 300 to make 7.3. So it's 2.3 to 7.3. It's very close to the 1 to 3 that I was looking for. And you can see now it's actually a lot more visible than it was before. Right? So if we say Merry Christmas, as we have been doing, I'm typing this into the serial, and there we go. It's not the easiest to see on camera, unless I, of course, bring it up closer. But at least the contrast is pretty good. Yeah, it's on there if you look for it. He's asking about the blinking cursor. And then I also took the time to trim all the resistors down so they'd fit better. There's one over here that is still not trimmed and it stands up. But these ones, since there's a lot of them, I trimmed them down and fit them in so they wouldn't take as much space. So now they just fit right into the board. Okay?
Okay.
Okay, and so that's the end of that one. See you all next time.
Yeah.